Yeah, that's an old one. All right, guys, welcome in. Thanks for being here. We're going to start a new topic today about uh, writing expressions. So, if you are watching on the YouTube channel, thanks for watching. If you're here in class, thanks for watching. Um, I'm going to go ahead and share my screen so we can get ready to roll here. Uh, here we go. And for your information, this is lesson 4-1, 4-1 in your book. So if you are following along, flip to lesson 4-1, and that will be very beneficial to you. I highly recommend following along in the book and doing these problems with a pen or a pencil as we do them in class. All right, so let's get started.
How can algebraic expressions be used to represent and solve problems? Think about this question during the lesson. An automatic dog feeder dispenses 2/5 cup of dog food each day. What expression can the dog owner use to figure out how much food is left in the feeder after D days? How can we use a bar diagram to represent this situation?
All right, we are going to write an equation. We are going to make an equation that models this scenario. All right, we are gonna, we have some information here, Josie. We have some information here that it says we started out with 20 cups of dog food and we have 2/5 cup each day. Josie Riley, you're gonna have to go outside in the hallway. 20 cups of dog food, and it dispenses 2/5 of a cup each day. Okay, so we want to know, when are we going to run out? When are we going to run out? So we're going to write an equation to model that. And first, it wants us to use a tape diagram or a bar diagram to represent the situation.
You can draw a bar diagram to represent the amount of food remaining in the feeder after D days. This measurement line represents the full amount of dog food the feeder can hold. One segment of the bar represents the food dispensed each day, and the same amount of food is eaten each of the D days. But there's also a segment of the bar that represents the remaining food in the feeder. What expression represents the food dispensed in D days?
Select your answer.
All right, so we're setting up this bar diagram, we're setting up this equation, and it wants us to, it went over here, but what represents the food dispensed in D days? So we know that 2/5 of a cup, or 0.4 cups, is dispensed out of this machine every day, right? And some people have these because if they work long hours, they can't always be home to feed their dog. So this automatically is on a timer, and it just puts out the same amount of dog food every day. So 2/5 of a cup each day, and we want to know how much food is dispensed in D amount of days. Okay, so what we would do there is multiply 2/5 times D, right? 2/5 times the number of days. So if the number of days was 10, we would say 10 days times 2/5 of a cup, right? Because that dog got 2/5 of a cup of food every day for 10 days. So 2/5 times 10 would give us the amount for 10 days. So we're going to pick this one, 2/5 D. We know that something, I'm going to put it down here and reselect it. We know that something next to each other with no sign means times or multiply. We know that. So I'm going to put this right here, 2/5 D, that's next to each other, represents multiplication, right? None of these other three, we're not going to add, we're not going to divide, and we're not going to divide, right? We need to multiply. Let's put that one right here.
The expression 2/5 times D represents the food dispensed in D days. So, what expression can the dog owner use to determine the amount of food left in the feeder after D days? Use the bar diagram to write an expression to represent the amount of food remaining in the feeder after D days.
All right, they kind of did it for us, right? What you need to do is, it said they started out with 20 cups of food. So we start out with 20, and then we are subtracting 2/5 times the amount of days, right? So if we want to know how much food is left after 10 days, we would have to do 2/5 times 10, right? Which would be 4 cups. And then we know that the dog has eaten 4 cups, so we would do 20 minus 4 to find the remainder, which would be 16. Okay? That's how we got this expression. We know that the amount of food the dog has eaten is 2/5 times D, or the number of days. And we know that we started with 20. So whatever the dog has eaten, we are subtracting or taking away from the original amount, which was 20, right? So that makes sense. 20 minus the amount of food the dog has eaten gives us the amount left. And this, of course, was the amount eaten after a certain number of days. Okay, let's start our own activity and try it. All right. Select the 3 parts of the equation to see what they represent. So we already know that 20 is the original amount that the feeder holds, right? The feeder holds up to 20 cups. Now, 2/5 is the amount of dog food that the dog eats each day, right? The dog gets 2/5 of a cup, or 0.4 in a decimal, right? If you punch in 2 divided by 5, you would get 0.4. 2/5 of a cup each day. Well, to know how many or how much dog food the dog has eaten, we then have to know how many days it's been, right? So the D represents the number of days, right? If we're looking at 5 days, 2/5 times 5 equals 2. So the dog would have eaten 2 cups. So we would do 20 minus 2, and we would have 18 left. We started with 20, we subtracted 2, 18 left, okay? So let's take a look at the next slide.
The dog owner can use the expression 20 minus 2/5 times D to determine the amount of food left in the feeder after D days. 20 is the total number of cups the dog feeder holds, minus the amount of food dispensed each day, 2/5 cup, times D, the number of days. Now that we've written an algebraic expression to represent this situation, we could use the expression to solve problems related to this situation.
All right.
What do these
So that was an intro. Josie, can you be quiet? That was an intro to how we are going to write expressions and equations to represent situations. All right, let's try one of our own here. Misumi started with $217 in her bank account. She deposits $25.50 each week and never withdraws any money. So it's important to know what these words mean: deposit and withdraw. What is deposit? If I'm depositing money, am I putting it in or taking it out? What do you know about deposits? If I'm depositing something, am I putting in money in the bank or am I taking money out? If I am depositing, I am putting money in the bank, right? If I am withdrawing, that means I am pulling money out. If I withdraw, I pull money out. This is in. Withdraw is out. Here, let's get you out in the hall. You're making lots of noise. Okay. Go get him in the hall. My kid has a fly swatter, and she's going around saying, "I'm going to get you, flies." Oh. All right. Can you go get the flies in the hallway so Dad can do math? Thank you. Bye-bye. All right. So we know the deposits go into the bank and withdrawals go out. If I go to the bank with a bunch of money or a check and I give it to them, that is a deposit. They're going to put it in my account. So her initial deposit right here is $217. That's how much money she put in. I don't know. Maybe it's after her birthday or after Christmas or something, and she got some money from her aunt and uncle and grandma and grandpa and whoever. They all gave her some money in addition to whatever else she got for Christmas, right? That happens sometimes, where you get a birthday card with $20 in it from your grandma or whoever, right? So she put $217 in the bank account. She started with $217, and now she puts in $25.50 each week. She never takes any out. Okay, she's trying to save up. So she's not taking money out. She's trying to save. So our expression here is going to be, what did she start out with? And then we are going to add what she puts in each week. So she starts out with $217, right? It told us that's how much money she starts with. Now she puts in $25.50 per week. Okay, so $25.50 times the amount of weeks. And I know my handwriting isn't the greatest, but I'm trying the best I can here. All right, $25.50 per week. So that is $25.50 times the number of weeks. As we know, two things that are next to each other without a sign in the middle mean we are multiplying them times, right? If I say 3 and then I put a 6 right next to it with a parentheses, we know that that means 3 times 6, which is 18. We know that this means times. Any two things that are next to each other without a sign in the middle, we are multiplying. Okay, so we have an equation here. Josie.
Hi. I was having problem with the internet, so I missed my class because of the internet.
Hey, Deasia, thanks for being on. That's all right. Hold on, my kiddo is shrieking and crying here. Okay, crisis averted. She's got her blanket back. She was screaming and shouting, "I want my blanket!" All right. Deasia, we are talking about writing expressions that make a function for a situation. Okay, so in this question, I'll just go over real quick. It says that this girl started with $217 in the bank, right? So that's our initial amount. She starts with 217. That's what she deposited. And now maybe she has a job or whatever. I don't know where she works. She works at Kroger bagging groceries. She deposits $25.50 each week and never withdraws any, right? Maybe she takes some of her money and puts it aside as spending money, and then all the rest she always puts $25.50 in the bank every week. So $25.50 times the amount of weeks is going to give us how much money we add, right? We start with 217, so it's 217 plus whatever we add, which is $25.50 times weeks. After 1 week, $25.50 times 1 is $25.50. So we add $25.50. That's common sense. After 10 weeks, she would add $25.50 times 10, which is $255. So we would do 217 plus 255 would give us the amount after 10 weeks. All right. But all we're doing here is multiplying 2550 times the weeks to get the amount she added. So it's that simple. It's that simple. We do our starting point, and then we're either adding or subtracting the amount times weeks, right? In the last problem we did with the dog food feeder, we were subtracting, right? Because we started out with 20 pounds of dog food and we were subtracting 2/5 of a pound every day. In this one, we're adding $25.50 every week. But it's the same concept. Obviously, if we're taking away, then we're going to subtract. If in this case, we are adding, we are putting money into the bank account. And we talked about Deasia, we talked about deposits mean we're putting money in, and withdrawals mean we're taking money out, right? That's important vocabulary to know, obviously for math class, but it's obviously important vocabulary to know in general in life. Deposit means it's going in, and withdrawal means it's going out. Okay. A lot of jobs nowadays, I would think maybe even most jobs nowadays have what's called direct deposit. So basically, what that means is direct deposit means you give your job your bank information, right? When you get hired to a job, and this is not all jobs, right? Especially jobs that like high school kids have. Sometimes they don't do that. They just give you a check at the end of the week or whatever. But a lot of jobs, you get hired, they will have you fill out a form with your bank account information. What bank do you have? You know, maybe you have an account at Fifth Third or KeyBank or PNC or wherever. You write down, I have an account at Fifth Third Bank. The account number is blah, 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 blah. The routing number of my account is blah, 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 blah. And then the employer, your job, will call your bank and set up a direct deposit. So instead of you getting a check at the end of the pay period every 2 weeks or whatever, some jobs pay every 2 weeks, some jobs pay on the 15th and the 30th. But instead of getting an actual check, the money goes straight into your bank account. Okay, that is called direct deposit, right? The money goes straight from your job, and at the end of the week, your boss just goes in and clicks pay employees on the computer, and it sends the money straight from your job's account into your account. So you don't have to cash a paycheck, right? And you don't have to go through all that hassle of going to the bank to deposit it. That is directly deposited automatically into your account, right? And again, a lot of jobs these days have that because everything is computerized and it's just easy. Makes things really easy. And it saves them money too. It saves your job money because they would either have to print you out a check or sometimes they might even have to mail you a check, right? And they don't want to spend that money on an envelope and a stamp and printing out a check or writing a check. They just want to click the button. It's easy. So anyways, that's deposit and withdrawal. Let's go to the next problem here. I guess we can do this. How did you determine which value to use for the constant and which value to use for the coefficient? Well, the constant is something that never changes, right? The constant is always the same. It never changes. So our constant is going to be 217 because we started with $217. We always are going to have that 217 because it says she did not withdraw anything. She never withdraws. But we're always going to have that original 217. That's the constant. And then our coefficient is this number right here that we're going to multiply by the number of weeks. 2550 a week times however long we go, right? Could be 2 weeks, could be 52 weeks, right? There are 52 weeks in 1 year. There are usually 4 or sometimes 5 weeks in 1 month, depending on how things shake out. So that's how we picked the constant and the coefficient. The 217 will never change, so we call it the constant, right? Constant means unchanging. Let's go to 4-1 example 2. The expression 999D plus 1299C can be used to find the total cost of D pounds of almonds and C pounds of cashews. How much does it cost to buy 1.5 pounds of almonds and 2.5 pounds of cashews? Okay, so D is the amount of pounds of almonds. I don't know why they didn't just use A, but they used D. And C is the amount of pounds of cashews, right? So you go to the grocery store, you're buying cashews and almonds, right? And some grocery stores have this where you can scoop it out. They probably don't have it right now because of Corona. They don't want people breathing on and all the stuff. But some grocery stores do have this where you can scoop out all kinds of different like vegetables and not vegetables, like dried fruits, like they have raisins and dried cherries and whatever. And then they also have maybe apricots, and then they have all kinds of nuts like almonds and peanuts and cashews and whatever, sunflower seeds, and you can scoop a bunch of stuff in, right? And you can just take what you want. So we've got this equation, 999 times D plus 1299C. Now, notice in this picture, what does the 999 represent? It represents the price of almonds per pound, right? Almonds are $9.99 a pound. Cashews are $12.99 a pound. So that's what the $12.99 represents right here. $9.99 times D, which is the amount of almonds, and $12.99 times C, which is the amount of cashews, will give us our total price. Let's go to the Jamboard and figure this out. All right, so we've got a function here. $9.99, $9.99. What do you think this is, Indiana? You guys are too young to know that commercial. I'm going to say equals the total, right? 999 times D, and we know that anything next to each other is going to be times, plus 1299C is going to give us the total price. Now, let's go look at the info. We bought 1.5 pounds of almonds, so we're going to end up doing $9.99 times 1.5. 1.5 pounds of almonds plus $12.99 times the amount of cashews, or cashews. Some people say it either way, tomato, tomato. Right? We bought 2.5 pounds of cashews. All right. So do you see how this works? The price per pound times the amount we buy is going to give us the total price. $9.99 for 1 pound times 1.5 pounds. We multiply by the amount we bought to give us the total price. It's that easy. I don't know why I just didn't hit the back arrow here. I don't know why I'm painstakingly deciding to erase all this, but whatever. Okay, so let's use let me do this. All right, so now you guys can see my calculator here. We know that 1.5 is the same as 1.5, right? If I punch in 1/2 into this calculator, 1/2, I get 0.5. So 1.5 is the same as 1.5 is the same as 1.5. Let me rewrite this. And this is 2.5, right? Because we know that 1/2 means 0.5. So let's rewrite all this stuff in decimals, because it's just easier to use decimals, in my opinion. So now we got Let's do the math. $9.99 times 1.5 is 14.985. Well, can we have three numbers in cents? Can we have a three-numbered cent? No, we can't. We cannot have a three-numbered cent, so we have to round it. So we need to round it off to two digits, or two decimals. 5 is 5 or more raised to score, so we're going to round this up to a 9, right? We need it to be two decimals. We're looking to round to this number. 5 is 5 or more raised to score, so this 8 is going to become a 9. So the price for the almonds is $14.99. And again, we round it up slightly. Now we have to add that to the price of the cashews. So let's do that. $12.99 times we bought 2.5 pounds of cashews. $32.47, and we have a 5 on the end. So again, we need to round to two digits. So we're rounding this 7. 5 is 5 or more raised to score. So we're going to end up with $32.48. We're going to make that 7 and 8 because of rounding. 5 makes us round up. 0 through 4, we would leave the 7 alone. Let it rest. 5 or more, we're going to raise the 7 up to an 8. So $32.48, right? So this is your price for the almonds right here, and this is your price for the cashews. And so our total, we just have to add them together, right? That's all we got to do. We got $14.99 plus $32.48 equals $47.47. That is our total price. Okay. For 1.5 pounds of almonds and 2.5 pounds of cashews. It didn't really walk us through that, but that's okay. Oh yeah, here we go. It's down here at the bottom. Let's check our answer. Right? We needed to make an expression for the total cost of almonds plus the total cost of cashews, which is what we got, right? $9.99 times D plus $12.99 times C. We plug in our values, 1.5 and 2.5, and we multiply those out. They did not round. If you were at a store, the cash register would have rounded these off. So they're going to get an answer that's 1 cent off from us because they did not round. But if we were at the grocery store, it would round this up to $14.99 and up to $32.48, right? There you go. So they got $47.46, all right, because they didn't round up. We got $47.47, which is close enough, right? We rounded because that's what the cash register would do. But they got what we got, so things are good. This to me seems good. The cost to rent a scooter is $15.50 per hour, and the cost to rent a watercraft is $22.80 per hour. Okay, so this place is like, I don't know, maybe it's some park somewhere, some national park or some park that's a downtown area. You know, you can rent those little scooters to drive around, the Lime scooters, or you can rent, you know, some places you can rent a little boat, like a paddle wheel boat that you paddle with your feet. You know, you pedal and it paddles. So it's $15.50 to rent a scooter per 1 hour, and it's $22.80 per 1 hour to rent a watercraft. Use the expression 15.5S plus 22.8W to determine how much it would cost to rent a scooter for 3.5 hours and a watercraft for 1 3/4 hours. Lots of information there. Let's go back and figure out what it's asking us here. We have an expression that they give us. They give us this expression here, 15.5S plus 22.8W. Let's rewrite this. 15.5 times S. S is the amount of time we rented the scooter, which is 3.5. right? And then we're going to add 2280 times 1 3/4 hours. This 2280 times the time we rented the watercraft is the cost of the watercraft. So then we will have to add those together at the end. But let's figure out what we got here. We know that 3.5 is the same as 3.5. So what I'm going to do is 15.5 times 3.5. That is $54.25. That is the cost to rent the scooter for 3.5 hours. Right? We're going to have to add that to the price to rent the boat. Ooh, my bad. $22.80 or $22.8 times 1 3/4. We know 3/4 is 0.75, right? Just like 3/4 in change is 75 cents. If you punch in 3 divided by 4, you're going to get 0.7. Excuse me. 0.75. So, 1 3/4. Man, I'm sorry. I'm getting something in my throat. 1 3/4 is, there we go. Now I'm back. 1 3/4 is 1.75, right? So 2280 times 1.75 is going to give us 39.9. Now, we can't have $39.9. We know we need to add a 0 on the end of it, which would make it 39.90 cents, right? Because we don't write dollars like this. We don't write dollars as 39.9. So if there's only one digit, we know we have to add a 0 to the end of it to make it 39.90. All right, so our total cost for the scooter plus the boat, the watercraft as they call it. I'm going to call it a boat. Okay, I call a spade a spade. 54.25 plus 39.90. Let's add them up. We already got our 39.90 in the calculator, so I'm just going to push plus 54.25. Here, 94.15. $94.15 is our total cost. So that is the total cost to rent a scooter for 3.5 hours, and then a boat for 1 3/4 hours, which would be 105 minutes. Right? That's the same as 105 minutes. All right, let's move on. Let's see if we got this correct. I don't even know if they're going to tell us whether we got it correct or not. This is one that we just had to do on our own. So there you go, 94.15. Is this making sense? Are we understanding what's going on here? Everybody on the same page with me? The price of the boat is $15.50 an hour, so we have to times that by the amount of hours. The price of the boat is 22.80 or 22.8 per hour, so we have to times that by the amount of hours we had the boat. Right? That's it. That's what we got. 94.15. All right, let's go on. Let's do one more. Malik and 2 friends earn M dollars. We don't know how much they earn, so we're going to use the letter M to represent it. Malik and 2 friends earn M dollars in 1 week doing odd jobs. All right, they're painting people's fence, they're mowing lawns, they're fixing shingles on roofs. Who knows? They're just fixing up people's houses for extra money in the summertime. Right? They earn M dollars. They're going to split the earnings so that each friend gets 1/3 of the total earnings. Okay, and that's fair, right? Because there's 3 of them. So they're going to split it 3 ways. They get 1/3. Malik gets 1/3, Jimmy gets 1/3, and Trey gets 1/3. So 1/3 plus 1/3 plus 1/3 is the whole thing, right? They're dividing it by 3. And that's what this fraction means. Anytime you see a fraction, you're thinking divide, right? This literally means 1 divided by 3. So they are getting 1/3 of the profits. Okay, they're splitting it 3 ways, even. Malik uses $32.50 of his earnings on lunch each week. Last week, the 3 friends earned $963. How much money did Malik have after paying for lunch? Okay, so it tells us a couple pieces of info here. The first one is that they made 963 as a team. The second one it tells us is that Malik spent $32.50 of his money because they like to go through the Wendy's drive-through or whatever to get lunch every day, and he gets, I don't know what he gets, but he gets lunch every day at Wendy's, so he spends $32.50. Okay, so the first thing we need to do is we need to find out what Malik's share is. This is the total amount of money that all 3 of them made. Okay, so we need to divide that by 3 because Malik's share is the total divided by 3. Let's write an equation here. 963 divided by 3 minus the amount of money he spent on lunch, $32.50. Equals well, it equals, that's how much he's going to have left. So let's figure it out. 963 divided by 3. That's going to give us Malik's cut. 963 divided by 3. That works out to a perfectly good even number of 321. So Malik's share is 321, right? Because that's what this is. 963 divided by 3 gets us 321. Now we have to subtract 32.50 because he spent 32.50 on lunch. Okay, and if we're really curious, 32.50 divided by 5 days in the work week, he spends about $6.50 a day on lunch, which sounds about right. That's how much a combo meal costs at a Wendy's or a McDonald's or a Chick-fil-A or wherever you go, right? He's spending about $6.50 a day on his lunch. So we subtract the amount of lunch money he spent from his total cut. So we have 321 bucks, and then he spends 32.50, so we have to subtract that. Well, how much does he have left? He has 288.5. Again, we cannot have $0.5, right? So what do we have to do? If we only have one number in the sense, we need to add a placeholder 0 to the end. After buying lunches, he has $288.50 left. Okay. That's how much money he will actually get to take home and put in his bank account. This brings up a good life lesson. Okay. If you spend money, you might think when you get a job, especially if you get a job in high school or whatever, or in college, you might think, oh, I'm getting paid plenty of money. I can afford to spend 10 or 12 bucks every day on lunch, right? Some people do that. Some people every day they go get lunch at Chipotle and they get a bowl with guacamole and chips and a drink and queso, and all of a sudden, all of a sudden they owe $13 a day for lunch. All right. If this was $13 a day times 5, he would spend $65, which would leave him with only 256 bucks. Okay. So the cost of buying stuff like that adds up quick. You're spending 10, 12, 13, 14 bucks a day on lunch or on snacks or whatever. Even a lot of kids, before they come to school, they stop by the convenience store and they buy snacks, and they'll buy like a pop and 2 bags of chips. That adds up every day. All right. So budget your money wisely. Personally, I try to pack my lunch most of the time. I try to pack my lunch because that saves a lot of money. Um, obviously it costs a little bit of something, but it only costs like $1.50, right? Because I'm using 2 pieces of bread, some turkey, some mustard, maybe a slice of or maybe one leaf of lettuce, and maybe one slice of tomato, right? To make a sandwich to take for lunch only costs me like $1 or something, as opposed to if I spent $10 a day, I'm wasting I'm wasting $65 a week, right? Whereas I could have only spent like $7 or $8 a week if I had packed my own lunch and just bought a loaf of bread and some turkey and a tomato and some lettuce, right? Or whatever you like to put on your sandwiches. All right. Let's go to our next slide and see if we got it right. They set up an equation. 1/3 of M. M is the total money they made as a team, right? So he gets 1/3 of it, 1/3 times the total team take minus 32.50 because that's what he spends on lunch. We just put in the total amount of money they made, which it told us was 963. 1/3 of 963 minus 32.50 leaves him with 288.50 left, which is what we got. Right? We got the same thing, 288.50. Lunch does add up. Buying random stuff you don't need adds up. So that's a good life lesson. Like whenever you're in the grocery store, you don't have to have a stick of gum or whatever from the checkout line. Whenever you're driving around, like whenever you're, packing for your week at work or whatever, pack a lunch. That's going to save you hundreds and hundreds of dollars over the course of a year. Like if he works at this job for a year and he spends $32.50 a day on lunch, and I don't know, if he spends $32.50 a week on lunch, it's $32.50 a week. Times there are 52 weeks in a year. He's going to spend $1,690 on lunch. Okay, if he would have packed a lunch, he'd spend $7 a week times 52 weeks in a year. He'd only spend $364. So he is saving like $800. He would save $800 if he packed a lunch. Okay, over the course of a year, he would save $800. So I think it's smart to pack a lunch. We all like to eat out every now and then, so it is what it is. But in general, it's smart to be frugal with your money. Frugal means you spend it very wisely. All right. Amelia earns $8.74 per hour plus a gas allowance of $3.50 per day at her job. That must be nice. They pay for a tank of gas, or they pay for a gallon of gas every day, or a little bit more than that, I guess. So her job is $8.74 an hour plus gas allowance of $3.50 per day. How much does Amelia's job pay in a day when she works 5.5 hours? Write an expression and evaluate. All right, so let's write an expression. She makes $8.74 per hour. Whoa. $8.74 per hour. So we're going to multiply that by H, the number of hours she works. Plus, she also gets an extra $3.50 gas allowance each day. So we are going to write, this is how much she makes per hour. And then we have to add the $3.50 gas allowance on the end. So whatever she makes, we'll do that calculation, and then we'll add the $3.50 on at the end. So it wants us to evaluate a day in which she worked for 5.5 hours. 874 times 5.5 plus 350 equals $8.74 times, we know that 5.5 is the same as 5.5, right? A half equals 0.5. So she makes 48.07 in hourly wages. Plus, she gets $3.50 for gas. Not many employers do that, but that's nice. Some do. If you have to drive your car a lot, or you're driving around the country selling stuff or wherever, you're going somewhere on business out of town, a lot of times they will pay you a travel allowance. 48.07 plus the $3.50 for gas gives us what? $51.57. That is the total amount of money they will pay her for the day. $51.57 is how much her paycheck would be for that day. Well, minus taxes. All right. How are we doing on this so far? Are you guys getting this concept? If we have an hourly rate, we are going to multiply that times the amount of hours that she worked. And then if we have a constant or a starting point, you can almost think of this as a starting point. Before she ever even works a single minute, just for driving to her job, they pay her $3.50, which is, I guess, supposed to cover the amount of gas it takes to drive to and from her job, right? So just from driving to work and clocking in, she already has made $3.50. That's her starting point. They say, okay, we're going to give you $3.50 for your gas today. Thanks for driving it, right? Then she starts accruing hourly rate. So the time she works for 2 hours, it's $8.74 times 2. She works for 8 hours for a full day, $8.74 times 8. Whatever the case may be, we're going to add that to the original $3.50. That was our starting point. All right, let's see what else we got here. Let's try one more problem and we will wrap up the day here. The water depth in a tidal river is 2.5 feet. The river is rising at 1.5 feet each hour. Write an expression to represent the depth of the tidal river after H hours. So it starts out at 2.5 feet. So that's our starting point. That's our constant. That's never going to change. It starts at 2.5 feet. Then it is adding another 1.5 feet of height per hour. So we're going to add 1.5 feet times H, being the number of hours, right? So we're going to pick this one. 2.5 feet is the starting point, and 1.5 feet times the number of hours is the rate at which it's rising. Write an expression for the depth after H hours. What will the depth be after 4 hours, right? So that would be this, right? 2.5 times 1.5 times 4, or sorry, plus 1.5 times 4. 1.5 times 4 is 6, right? 1.5 times 2 is 3. So we know 1.5 times 4 must be 6. So after 4 hours, the river has risen 6 feet. Then we just got to add that to the original depth. 2.5 plus 6 is 8.5. It's going to show us exactly the same thing. They set up the equation. 1.5 times H is that's the distance the river rises, right? In this case, it's 4 hours, which means it rises 6 feet. We add the original 2.5, we get 8.5. All right, I'm going to open it up for questions. Is there anything you would like me to talk about? If not, I will get you guys started on some Delta Math, and you guys can catch up on homework. So I'll open it up. Questions, comments, concerns, questions about the homework. Do you want to use this time to just work on an assignment? What are your thoughts, class?